In this video, I'll introduce you to points, circles and arcs in detail, and we will see the various methods to construct these objects in AutoCAD. We will start with a point. A point in AutoCAD is a node which will act as a place marker to construct so many other objects. A point has got absolutely no size and it can be constructed using a variety of options. So if you want to make a point, just give the command PO using the keyboard and you can just make a click to get a point on the screen. A point by default is represented like a dot. Now I'll right click, repeat point, dot, right click, repeat point, you have got another dot. Likewise, you can plot as many points as you want at the required locations. But this method is not accurate since these points are plotted at random. We also have a little difficulty to identify the points because they are represented like dots. So what I'll do is I'll turn off the grid and I'll change the representation of a point using a command that is called DDP type. DDP type stands for Dynamic Dialog Point Type. You can choose any representation from this dialog box. Suppose if you click here, your points will be represented like a cross. But if you click here, you will have a different representation. You can also change the size of a point and it is specified in terms of the screen size. The default size is 5% of the existing screen size. If you want, you can give it a higher value. I'll make it say 10. Now the size of the point got enlarged. I'll give an enter to go back to the same dialog box and I'll set the point size to 5. Now I would like to create these points precisely at predefined coordinate locations. I'll select all these objects and hit erase. I'll give limits command. I'll keep the lower left at the origin 0, 0 and I'll set the upper right corner at 120, 60. Now I'll give a zoom all. Now I'll pan the display slightly in the upward direction to see the origin point clearly. Next I'll give point command. When I'm asked to specify a point, I'll give the x coordinate of the point as 50 and the y coordinate as 25. Now you can see the point clearly here in the new representation. And this point is at precise coordinate location. When I say x coordinate of this point is 50, that means this point is at a horizontal distance of 50 units from the y-axis. When I say the y coordinate of this point is 25 units, this point is at a vertical distance of 25 units from the x-axis. And the reference point is the origin. This method of point entry is called absolute coordinate method. As you are already aware, AutoCAD always memorizes the most recently given command, which can be repeated by giving an enter. Similarly, AutoCAD also memorizes the most recently defined point. You can get access to this point at any point of time by inputting @ before you enter any other point. Let's see an example. I'll give an enter to repeat the point command. Now when I'm asked to give the point, I'll start with @ symbol. @ will be interpreted by the software as with respect to the last point. Now I'll enter the coordinates. Let it be 30, 20 and enter. Now you can see that this point is plotted with respect to the most recently plotted point, which was this point. So this point is at a horizontal distance of 30 units with respect to the most recently plotted point and at a vertical distance of 20 units with respect to the recently plotted point. And such method of point entry is called relative coordinate entry method. In this method, you can always refer the most recently plotted point to plot the next point simply by inputting @ before the coordinates of the next point. In the next method, we define a point by inputting distance and angle. Distance between the point to be plotted and the reference point, which is the most recently plotted point, and the angle made by the line joining these two points with the x-axis or with the 0 angle. This method of point definition is called polar coordinate method. We have provided the same set of parameters while constructing lines using the dynamic input method. But for a point, dynamic input won't work. Now let's try polar coordinates. I'll just zoom out and pan the screen slightly leftward and I'll give a region command, type RE for region to see the point in the actual size. Next I'll give PO for point. Now when I'm asked to specify a point, I'll give @ because I want to refer the most recently plotted point. Then I'll give a distance. Let it be 45 units. Then I'll type less than sign. Less than indicates the angle. I give 60. Give enter. That point is not visible. It must have gone slightly outside the screen. So I'll just zoom out a bit. Now you can see that this point is at a distance of 45 units with respect to this point. And the line joining these two points makes an angle of 60 degrees with the horizontal. Polar coordinate method can be either relative polar method or absolute polar method. Just now we have used relative polar method, in which we have referred the most recently plotted point to plot the next point. That is why we have started with an @ sign. The polar method can also be absolute, in which you directly enter a distance and angle without starting with @ sign. Let's see an example. So I'll give PO for point and I'll enter 30 less than 45. Now there is no @ sign. When you give it, you can see that this point is at a distance of 30 units from the origin. So the reference point is the origin, and the line joining the origin point and this point makes an angle of 45 degree with the x-axis or with the 0 angle. So this is what is called absolute polar method. Now, where do you use all these points? As I told you before, points will act as place markers in AutoCAD, which can be used as references to create any other object. For example, a surveyor can plot all the data points obtained after a survey, and he can draw lines connecting all these points to indicate the land. And these points can also be plotted in 3 dimensions. So you can actually create the land in 3 dimensions, which is really great. So let's draw lines connecting these nodes. So I'll click on the line command. I want to get this point. If you want to catch this point, you have to activate the node option in the object snap. We'll have an exclusive session on OSnap in the coming tutorial. Anyway, I have activated node. Then I've started from this point to this point to this point to this point. Hence, I have used these nodes as references to construct lines. So that's all about points. Now we will move on to the next object in AutoCAD, which are circles. You can draw a circle in AutoCAD using a number of options. When you click on the circle command at the draw panel, you will see a flyout wherein these options are displayed. Even if you have a number of options to draw circles, center radius is the most frequently used one. So I'll click on center radius. It will ask you for a center point. A center point can be defined using any of the normal point definition methods. So I'll just click on this node as a center. Now it will ask you for a radius. I'll give 30 units as a radius. Now the circle has got a center at this point and it is drawn with a radius of 30. Next, I'll draw a circle using center diameter method. So I'll click on the circle command and I'll select center diameter. I'll define the center point using absolute coordinates. I'll give 140, 50 as a center point. Now it's asking for the diameter. I'll give a diameter of 50 units. So the circle is drawn with the center diameter method. Next, we will see 2-point. 2-point option will let you draw a circle passing through any 2 points on the screen. Suppose I want to construct a circle passing through this node as well as this node. So I have got such a circle connecting these 2 nodes. You can also give precise values to draw such a circle. So I'll click on 2-point again and I'll pick the first point of the circle here. And suppose I want the diameter of the circle to be 60 units. When I'm asked to give the next point, I can define that next point using relative coordinates. So I'll give @ with respect to the last point 60, 0. So the second point is at a distance of 60 units with respect to the first point horizontally rightward. I'll pan my screen to make some space over here and I'll go to circle command and I'll choose 3-point option. 3-point is just like 2-point, but instead of 2 points, you specify 3 points on the screen. And AutoCAD creates a circle passing through these 3 points. So I'll click on 3-point, I'll specify the first point, second point, and depending upon where you specify the third point, AutoCAD automatically adjusts the position of the circle in such a way that it passes through the 3 points. Suppose if I specify a point which is almost in line with the first 2 points, you might sometimes think that you're actually trying to draw a line instead of a circle. Let's see what happens. I'll just double tap the scroll wheel of the mouse to get a zoom extents. Now you can see that this is the circle you have drawn. When you just zoom in, you will see the points enlarged because of the magnification. Just region to regenerate the display. And this was the circle you have drawn. So I'll undo the operations I have done. Now I'll make a square. So I'll click on the rectangle command. I'll click my first corner here. Now I'll go to dimension option. So click on dimension. It will ask you for a length. Let the length be 100 and the width be 100. Now it's a square. Next I'll go to 3-point option. It will ask you for the first point, second point and the third point. Now you could inscribe a circle inside such a square using the 3-point option. I'll pan the display some more to make some space and I'll draw 2 lines by picking points. The next option to construct circle is tan radius. Using this option, you can construct a circle which is tangential to any 2 existing objects. When I take this option, I'll get a prompt that is specify a point on object for the first tangent of the circle. That means I want the circle to be tangential to this line. Now it will ask you for a second object, which is this line. Now it will ask you for a radius of the circle. I'll give 55 units as a radius. Now you have got a circle, and this particular circle is tangential to these two lines. In other words, you can say these two lines are tangents to the circle. And how will you define a tangency between a line and a circle? At the contact point, the radial line will remain perpendicular. The next option to construct a circle is called tan, which means that using this option you can construct a circle tangential to any three existing objects. So I'll draw three circles using center radius options, and I'll go to tan option. So it will ask you for the first object, second object, as well as for the third object. The moment you pick these three objects, you will get a unique circle which is tangential to these three circles. And how will you define the tangency between two circles? For that, I'll draw a line from the center to this intersection to the center. That means the radial lines passing through the contact point will remain collinear. It will lie along the same straight line. So we have covered all options to construct circles. Next we will move on to arcs. Arcs are nothing but portions of circles. In AutoCAD, we can create an arc either by trimming or breaking a circle, or you can create an arc directly. To make an arc, you can use a number of options. As you can see here, you can use start point, end point, center point, radius, second point, included angle, chord length, and direction. But at a time, you don't need all these options. You can take any three options out of these 8 options and you can create an arc depending upon the parameters available. And you can see the combination of all these options in this menu. Simplest of all this option is 3 point. That means if you can specify 3 points, 1, 2, 3, you can create an arc. And these points can be specified using any of the point definition methods which we have discussed before. I'll show you another example. Using start point, center point, end point, I can define the start point, center point, as well as the end point. Depending upon where I pick my end point, I'll get a corresponding arc. And if I choose start point, end point, direction, for example, I can pick a start point, end point, and I can show a proper direction. Depending upon where I point, I'll get the bulge of the arc in that particular direction. And another example is a start point, end point, included angle. I can select a start point, end point, and if I want to construct a semicircle, I should give an included angle of 180 degrees. So I'll give 180 and you will get a semicircle. Rest of the options are very simple and you can try these options on your own. And if I click on continue, I can draw an arc from the endpoint of the most recently drawn arc. I can again click on continue to continue drawing arcs. And this option will be particularly useful to construct irregular shapes. That's all about arcs. In the next video, we will see the methods to achieve precision in AutoCAD.